Hi students. Now today we discuss about the solutions of a partial differential equations. Solutions of a partial differential equations. So in this we are going to discuss about the how to solve first order. Okay? First order linear partial differential equations. How to solve first order partial differential equations. In the first order partial differential equations we have two types. One linear differential equations and second one non-linear differential equations. Okay, linear differential equation and non-linear. What is a partial differential equations of first order? You know that a differential equation involving partial derivatives like p and q. P is nothing but dou z by dou x, q dou z by dou y. Only p and q, and no higher order derivatives. That means no higher order means dou square z by dou x square, dou square z by dou y square, dou square z by dou x dou y, and more than that. So nothing any higher order derivatives involved in the equation, in the differential equations. Only p and q is called first order partial differential equation. Okay. So now if p and q, so what is the linear partial differential equations? Okay, what is the linear partial differential equation means if p, small p and small q occur in the first degree. Okay, occur in the first degree, it is called a linear partial differential equation. For example, here px plus qy square is equal to z. You can see this. What is the degree of p? 1. Degree of q is 1. So this is one of the examples we can take as a linear partial differential equation. Okay, now let us discuss non-linear partial differential equation. If p and q occur other than first degree, means a degree like p square, q cube like that in the equations, if we other than first degree, okay, it is called a non-linear partial differential equation. For example, you can see this is one of the examples. P square plus q square is equal to 1. You can see here the degree of p is 2 and q is also 2. Okay, other than the degree of 1, if you find in the differential equations the p and the q, okay, then it is called a non-linear partial differential equations. Okay, now so let us discuss the one of the important in the Lagranges linear equation. Lagranges linear equation. What is the Lagranges linear equation? A linear partial differential equation of order 1. Okay, remember, a linear partial differential equation of order 1 involving a dependent variable z and two independent variables x and y. Okay, a linear partial differential equation of order 1, remember, so it's a linear differential equation. Okay, and involving a dependent variable z and two independent variables x and y of the form like this: capital P into small p plus capital Q into small q is equal to capital R. Okay, as you know, the small p and small q is nothing but dou z by dou x and dou z by dou y. And what about the capital P, capital Q and capital Q R, where capital P and capital Q and capital R are the functions of x, y, z. Okay, is called Lagrange's linear equation. Okay, is called, here you can see this, where capital P, capital Q and capital R are functions of x comma y comma z, is called Lagrange's linear equation. Okay, now how to find the general solution of the linear equation? Okay, how to find the solution? There is then the general solution of linear equation of this form. That is, actually we seen that in the formations of partial differential equations by eliminating the arbitrary functions, we know we are getting solutions. Okay, just by eliminating the u and v, the functions here phi. Okay, by eliminating the function like these models, the problems, we are getting the partial differential equation of this form: capital P into small p, capital Q into small q is equal to R. Okay, capital P into small p, capital Q into small q is equal to R. Okay, so is derived by eliminating arbitrary function phi. Okay, now suppose that equation 2 has been derived from equation 1. So the equation 2, that is capital P small p plus capital Q into small q is equal to R, is derived from the equation 1 is this. Okay, something like phi of u v is equal to 0. Then this phi of u of function of, that is phi of or u f of, it is called a general solution of that Lagrange's linear equation or general integral of the Lagrange's linear equation. Okay, note here, remember one more point here. In the place of phi of u comma v is equal to 0, which is the general solution, it is called, the function relation can be written as u is equal to f of v, and this function can also be written in this form. Okay, so now let us discuss what is the working rule to solve the Lagrange's linear equation. Okay, working rule to solve the Lagrange's linear equation. Step 1, yeah, write down the subsidiary or auxiliary equations like in this form. Okay, you know the capital P and capital Q and capital R. You add the subsidiary equations or auxiliary equations. Dx by capital P is equal to dy by capital Q is equal to dz by capital R. Now the step 2, find any two independent solutions of the subsidiary equations. Okay, find any two independent solutions of the subsidiary equations. Let the solutions be u is equal to a and v is equal to b. So we will get the two independent solutions by equating any these two or first and the last. By equating these and these members, we will get two solutions, two independent solutions. Okay, we will take that as a step 3. Now the general solution of Lagrange's linear equation is given by f of u comma v is equal to 0. That is means function of u comma v is equal to 0 or u is equal to f of v. Okay, now to solve the subsidiary equations, how to solve the subsidiary equations? Okay, to solve the subsidiary equations, okay, so like this, dx by capital P is equal to dy by capital Q is equal to dz by capital R. So we have two methods. The first one is method of grouping and the another one is a method of multipliers. First, method of grouping. Okay, so in this how to find the solutions means just by equating the first two members, that means here these two or the first and the last. By equating these two, you can directly solve these equations to get the solutions, the two independent solutions like this. v of xy is equal to c1 and v of xy is v of yz is equal to c2, or w of zx is equal to c3. These gives once you will get the two independent solutions, so that can be taken as the complete solution of the Lagrange's linear equation. Okay, Lagrange's linear equation. I hope you understand this. Okay, thank you.